Okay. So this is where we had left. Okay, and we spoke about different types of learning, right, and how they are different, how the data, what
Yeah.
kind of data we are trying to predict. That's what you see in this row. Okay, the third row. Okay, is the kind of data that we are predicting. So we are talking about categorical or continuous. So basically, if you see, the kind of decision that we make in life is two part, right? How much, like how much should you pay for this? Okay, is it then you negotiate, isn't it? So how much can we pay? And second thing that we look at is uh, which option to select, right? You'll have multiple options, like what which book to buy, to read, which uh, where to go for holidays, right? How much to pay? Okay, should I buy, right? So mainly, okay, these are the two types of decision that we make. Okay, and based on that we discussed that there are different algorithms. So let's go one by one. Okay, let's talk about regression. Okay, now regression, as I said, is about predicting the text data, sorry, not text data, continuous data. Okay, or your numeric data, how much, right? Example is house price prediction. Okay, if you invest in a land or in a house today, and you are trying to predict how much it is going to be after 4 years, 5 years, right? And based on that, you calculate how much returns you are going to get, right? So this is what regression is about. Regression is about how much to produce, how much to how much it's going to be, right? So whether it's talking about house price prediction, or you're talking about um, second example could be how many marks, let's say, students is going to get, right? How much the GDP of the country is going to grow up to, right? How much, let's say, any numeric for that matter. Okay, any numeric we use regression. So when Y is numeric and it is part of supervised learning where you have labeled data, you have to use regression family of algorithms. Of course, in regression also you have
But we
many.
don't have an output for it, right? I mean,
You
we
have
don't have,
output, right?
yeah, so we don't have a result data
We
to
don't have
look
what
at.
data, sorry.
So for like supervised learning, you need, I mean, you need like result set of data to
Correct.
compare with, yeah.
That's
So
what
here we don't have, I
label
mean, if,
data.
yeah, if say if I'm like predicting the housing market, I mean, what data do we have for the result? We don't have any data.
Correct. Now let's say, see, if you do not have any data, you cannot predict anything. Okay. Now let's say if
Yeah.
I ask you, okay, Harare is capital of Zimbabwe. Okay. If I ask you, Sweta, I bought a house today in Harare. How much do you think the house of the land would, the house of the price, I mean, house price would be after 5 years?
I will
What
know.
what will you answer?
I mean, I have to do some research, but otherwise I will
You
know
have no
that.
answer, isn't it?
Yeah.
But if
No.
I ask you that I bought a land or house in your locality, how
Uh-huh.
much do you think the house price would be? So will you not be able to answer to
Yeah.
something, right?
Yeah.
Why?
Yeah.
Because you have the data, right? You have
Yes.
the data. You've been tracking. You know what's been happening for last so many years.
Mm-hmm.
Okay. Now you get it right or wrong. That's not a thing. See, when we are doing prediction, prediction
Mm-hmm.
will always be wrong. Okay, you
Mm-hmm.
cannot predict up to 100% accuracy. But we are
Mm-hmm.
predicting to make sure that you have some plan, right? So now if I ask something about Africa, you have no clue and so sorry, I don't even know that it's going to go down or go up. But if I
Mm-hmm.
talk about your locality, in a way, okay, you track, what happens, what happens, okay, when hospital comes up in that region, or there is a big shopping mall that comes up, or there is a corporate office, corporate building that
Yeah.
comes up. All these are going to increase the rental value, and so the value of the property, right? So you have some idea, right? Same
Uh-huh.
thing I'm trying to say that. See, the one that you're trying to predict, you may not have the idea. Okay. You may not have idea about how many marks the students are going to get this year. but you have idea, based on last year data, how much student gets in their examination. Okay, simple way to understand. That logic you are going to extend to the new student, right?
Mm-hmm.
So if I ask you what's going to be the land price of the house that I'm going to buy, even though you don't know, but you know generally about that market, that city, that town, okay? So
Yeah.
in that locality, so you'll be using some kind of logic and give me some answer.
Okay.
So you have why, okay? Why? So prediction means, of course, you don't have, that's why you want to predict, but you
Yeah.
have something similar to that,
Yeah. Yeah.
right? So you have something similar. That's what I said, that you have data about last year. Okay, you're using last year data to predict this year. Okay, that's an example of supervised learning.
Okay.
And of course, you're predicting number. So it is your regression. Housing price is an example of your regression. And regression is a family of algorithm. Okay, and it will have many algorithms. Okay, we are going to do few, and just to give you an idea. Okay, and then you can explore more on your own self.
Okay.
Okay, now so as I said, you will have multiple x, multiple features. Okay, it could be 1 2 3 400 thousand features, and your y would be exactly one column. Okay,
Okay.
so and all these x has to impact y. If there is no relation between x and y,
It's an
then
one. Mm-hmm.
obviously you can't predict. There has to be some relationship between x and y. So when you talk about different algorithms, each algorithm has a different logic of exploiting or using this relationship. Okay,
Mm-hmm.
every algorithm has its own logic, and our job as a data scientist is to make sure that we understand that logic from the data and then use a particular algorithm. Okay, so every algorithm has one way of predicting or forecasting what will happen. Based on
Mm-hmm.
the see, you cannot use same method to predict car sales versus to predict, let's say, rice sales. Right, a retailer wants to predict how much rice it's going to sell in next month is probably much easier than predicting car showroom how many cars is going to sell next month. Okay,
Yeah.
because your food, mostly rice and the bread, these are standard, right? We don't increase or decrease the consumption based on our salary. Let's say if salary goes down, you're not going to reduce eating rice. If our salary goes up, we don't start eating more of rice. But
Mm-hmm.
cars, yes, right? If general condition is bad, people will buy less car. If they're good, people will buy more expensive car. So,
Yeah.
so the way you will predict rice versus car is totally different. The algorithm that will help you to predict rice will not be the algorithm for sure to predict cars. You have to figure out different algorithm to predict cars. So we're trying to understand the relationship pattern, and based on the pattern, we are going to pick the right algorithm. But all this algorithm will belong to regression. There are, okay, when I say regression as a classification, as a group, okay, not as a classification as an algorithm, but as a group, regression is supposed to perform certain activity, which is take the label data or your supervised data and predict the outcome, which is numeric value.
Okay.
The same supervised data, question here is yes, no kind of thing. So we have classification where your output is categorical value, yes, no. One
Mm-hmm.
example is medical imaging. Okay. Now, when let's say somebody goes with some problem, okay, fell down and let's say hand is paining, knee is paining, you know, so you go and they'll take X-ray, right? And based on X-ray, doctors are going to forecast or going to predict if there could be a fracture, right?
Mm-hmm.
So now, why this is supervised? Because we'll talk about doctor and then we'll come to medicine. Oh, sorry, then we'll come to the machine. So doctors will be taught in their medicine schools, right? How to look at an X-ray report,
Yeah.
right? And you will probably go through hundreds of X-ray reports, and they know how to read X-ray report. So they
Yeah.
use same knowledge to read a real X-ray report when they're at work. Okay.
Yeah.
Now, what we're doing is in our machine learning model also, we are passing many X-ray reports to the machine to learn. Okay,
Okay.
exactly the way you teach a doctor. Okay, same way you are passing multiple X-ray reports to the machine, and you're saying if the report has problem or not. Okay, so based on classification, as the classification is, it's not going to give you numeric value. It's going to give you apple, banana example
Yeah.
that you see.
Yeah.
Okay, where you are able to segregate into label data. Okay, so it's like where apple, banana, cherry, and grapes. So you are going to segregate them into label data. That means label group. Okay, which X-ray report has problem, which X-ray report does not have problem, because you've been taught, right? So you've been taught what is apple, what is grapes, what is cherry, what is banana. So it becomes easy for you to segregate these items into four groups. Similarly, okay, based on the medical image, okay, uh, uh, the doctor or the machine here in our example, machine has to predict whether surgery is required or not, or let's
Mm-hmm.
say bandage is required or not, right? I mean, so you're saying what? Yes, no, problem or no problem, right? So based on
Yeah.
X-ray reports or whatever input that you give, it's going to analyze and then tell you yes, no. Yes means there is problem, or I mean there is no problem. No means there is problem, right?
Yeah.
And then you can um, use that for other analysis. But
Mm-hmm.
our machine is going to tell us if there is a problem or no problem, yes or no, right? And no obviously means there is no problem. Okay, yes means there is a problem. So we are classifying into two groups, yes, no group. We
Mm-hmm.
classify into multiple groups as well.
Mm-hmm.
Okay. So depending upon the number of categorical values, number of groups will be created. If a categorical value has 5 unique values, 5 groups or 5 classifications will be created.
Okay.
Okay. And the job of machine algorithm is to predict each row as part of one of these 5 groups. So each row will be marked as A, B, C, D, or E.
Okay.
Okay. So that's about your classification. Now coming to clustering. Clustering is same, a fruit example, but here you don't know the names of the fruit. You don't know the Y value. You don't know the output. Okay.
Mm-hmm.
Example is customer segmentation. Okay. Um, I'll give an example and then we'll talk about it. So let's say Amazon. Okay. Amazon .in or .com or what your country it is belongs to, CA for Canada. Okay, it has to identify all its customers and make some recommendation. Okay, so you
Mm-hmm.
will get probably once in a week recommendation from Amazon, once in a day, once in a week.
Mm-hmm.
Now you see that Amazon has, okay, um, hundreds and thousands of products, right? So they would be running promotion, or they would want to send information about hundreds of products to us.
Mm-hmm.
Now, the challenge here. One challenge is if they start sending too many emails to us, we will block them, right? But we don't have time to read 10 emails from Amazon in a day, right?
Yeah.
So Amazon knows that if Amazon tries to send us 10, 20, 30 emails a day about everything that is happening at Amazon, we may not like it.
Tax expert. Sorry. Yeah.
Okay. So Amazon knows that we may not like it, right? We may not like it. We will block them, or definitely not. We will not even look at the email which probably is most relevant to us.
Mm-hmm.
So Amazon doesn't want to send all the emails to everyone. Amazon says, no, I'm not going to send every email to everyone. I want
Mm-hmm.
to segment my customer. I want to
Mm-hmm.
group my customer, okay, based on the nature, and based on the nature, I'll decide what should I do. So you're creating groups.
Mm-hmm.
Okay, they're creating groups, so that group is like based on characteristics. Okay, how much money do you spend, what time of the day you spend, what category you spend, how much you spend, like month, are you spending monthly, weekly, daily, ticket item. All those factors could be the features based on which, okay, Amazon will be or is looking to group a student or segment a student. Okay.
Okay.
So same thing, we discussed that when you don't know the name of the fruit, still you'll be able to put all apples together based on the shape, size, characteristics. So based on the
Similar.
characteristics, okay, you will say, okay, this is group A, this is group B, group C. Okay, and based on the characteristics, you will send email to group A only. Okay, so you'll find out that, let's say, group A are the people who loves to read books. So if there is any book related information, you will send only to group A, not to everybody else.
Mm-hmm.
Everybody else might be interested. Okay, and that's the problem with machine learning as well. See, machine learning is not, it cannot predict what your taste, it is going to predict based on what taste you have. But let's say if you want to change your taste, if you want to change your interest, then machine learning will not allow you to do that.
Mm-hmm.
Right? Because let's say, you love books but you want to buy dresses, but you have bought so much of books from Amazon. Amazon has put you along with other people in group A, which focuses on people who reads book.
Books. Yeah.
So now, if you want to change your interest or genre, or it's not very difficult. I mean, it's not very easy because you'll be keep getting messages from books, and you'll be fed
Yeah.
up. Okay. So see, the sad part of prediction is that since we are using your past data to predict, okay,
Mhm.
we may not know what you might like, which you don't know,
Yeah.
right? So in dresses, I have no idea about what you like. I know only about your book choices. I'll bombard you with so much of books that uh, you will not be able to change your mind about something else, right? So that's the sad part about data science, machine learning, that it is on past data, so it's not going to see your mood change, but yeah, you have to take steps. Then that's when, and this customer segmentation, these are not permanent. Okay, it doesn't mean that if I create and I put you in group A, you'll be in group A forever. Maybe
Forever.
after
Yeah.
3 4 months, you start changing your
Yeah.
behavior.
If you buy a lot of, if you buy a lot of
Correct,
something else.
correct. So they do it in once in a month kind of scenario where they refresh the data, and you might move to group C, group D. Now, in this case, you see, the name doesn't really matter. Unlike classification. Classification name is important. Should I perform surgery or not? Right? So you cannot say, okay, group A, group B. There I need to know, yes, surgery is
Exactly what.
required, surgery is not required. But in
Yeah.
this case, you say group A and you say group A is book lovers. Perfect. That is enough. Okay, so that's why here, okay, Y is not required. You are working on the characteristics and you are trying to create your own group.
Mhm.
Customer segmentation is trying to create own group, various groups, and then Amazon or any of these companies, they will start sending specific information to that group. Okay,
Yeah.
not all information is sent to everybody because it's going to bombard them with 20 such things. Okay, you don't want to send the product details which I may not be interested in.
Mhm.
So you will send me only to the product details which I'm interested in.
Mhm.
Okay, so that is what your clustering is. Association talks about which two products output are associated or linked to each other. Okay. Example is market basket analysis. When you go to retail stores, okay, you will see
Mhm.
that you get offered like buy this, get this free.
Yeah.
How did they realize? How did they come up with this concept of buy shampoo and get so free? Okay, because they
Because they
figured out
data,
this.
they had they, yeah, because they looked at the data like for frequently bought together
Correct.
product.
So that is called association. You look at the data periodically for few weeks, a few days, and then you figure out that, oh, shampoo and soaps are going well together. That means people who are buying shampoos also buys milk. 70,
Mhm.
80% of people who buys shampoo also buys soap. That means your soap and um, uh,
Shampoo.
shampoo goes together. Okay, and if you can package them something, it can help your business,
Uh-huh.
right? So that is called association. It's about finding relationship between two variables.
Uh-huh.
Okay, so these are your four basic types of algorithm, and everything else is a part of, is related to this classification, clustering. Okay, now here you see, uh, so you understood unsupervised also, right? So
Yeah, yeah.
unsupervised, again we are talking about which two products gel well. Okay, and then you can put them together. Okay, so what happened was, it's a true story and long time, decades old, more than maybe 10-year old. People
Mm-hmm.
in Japan, okay, or a shop called 7-Eleven, they were putting um, the Japan, they have closed the business. I think US, they are still there. So
Yeah.
7-Eleven started putting
Yes.
beer along with milk and bread, along with
Uh-huh.
milk, and the sale of beer increased. So 7-Eleven, had this concept, okay, where they will not sell same product entire day. In Japan, you have very the real estate is very
Short.
expensive.
Uh-huh.
So they'll have very small stores. So what they used
Mm-hmm.
to do is morning they'll have some set of product. Okay, in afternoon they'll have different type of products, and in the evening they'll have different set of products. So they keep changing the product based on the customer demand, right?
Okay.
And they realize that in the morning, okay, when people generally come to buy milk and bread, they were also buying beer. So they did not understand. Association said there's a beer associated with milk, and they were like, "What? I mean, how is that possible?" And they
Mm-hmm.
did some research. They figured out that generally in the morning, men would come to buy milk and bread, right? The family would
Uh-huh.
send men to buy, and
And yeah.
since men is already coming to the store to buy, so they would buy beer can.
Yeah.
They're
Can.
not going to buy the beer can to drink in the morning, because see,
Yeah.
you're going to the shop, so why, you don't want to come again in the evening, so you'll buy
Yeah.
stuff, put it in the fridge, and you drink in the evening, not in the day.
Mm.
But since you're going to the store, you buy it for yourself. And they figured out that, okay, and they started putting beer along with milk, and it the sale actually increased. So you are reminding people that, okay, you can do this also, right?
Yeah.
Okay, so that's the association rule. Classification, you have text classification, right? So what is the problem here? Okay, problem is handwritten notes. Okay, handwritten notes I want to convert into electronic format. Okay, so this process here is two-step process, and semi-supervised, you see, as the name suggests, semi. Okay, that means you know half you can say supervised, half unsupervised. So there's a two-step process here. Okay, it's not
Mm-hmm.
single-step process like previous cases. Here, so when you say text classification, text classification means you are reading handwritten notes and you are
Mm-hmm.
trying to predict what you have written. So if I write A in pen, the first job is to for you is to okay, for you in the sense, let's say you are the researcher, or for machine is to figure out that it is A, right?
Uh-huh.
So now when you actually go through text or something, there will be
Uh-huh.
meaning. Sorry, go ahead.
No, no, I'm good.
Okay. So when you are reading some document, let's say handwritten document, it's possible that same variable would be appearing more than once, right? 10 times, 15 times, right?
Yeah.
So and and since it's handwritten, they may not be exactly same. There will be some difference. You cannot write two exactly same looking element. There will be some difference. And when you are
Mm-hmm.
doing, 30, 40 times, maybe 5, 10 times, definitely the way, the same A might look little different. Okay, not to our eyes, but to the machine, it could little different. So what machine does is first it looks at the data and kind of uh, codifies. Okay, that means you look at the data, you say, okay, all these are A, all these are B, all these are C, all these are D. So first you're grouping, irrespective of knowing their name. So you'll say group A, group B, group C, or group 1, group 2, group 3, group D. Now, once that is done, that is called classification. So classification will help you to figure out all the symbols in this case,
Mhm.
okay, all the symbols, um, uh, like all the signs that you have as one group. Okay, so the way you write A, all A's will be put as one group. Okay, there could be some clash between A and Q. A and Q might look similar, and maybe if you distort A, it might look like Q also. So in that case, A will go to the Q group, something like that. Okay, so you can have that. That is error. Okay, as I said, right? Nothing is 100% accurate. So
Mhm.
you have to first you have to cluster them without knowing what they are. Okay, oh, this looks like something like this. And then you have to run classification. So you are using both clustering and classification, since last algorithm is classification, because now you have to name the group, isn't it? Naming is done using classification. So you are naming it, and that becomes your classification example. In clustering, okay, first thing is you need to figure out, okay, in an example is lane finding on GPS. So when
Mhm.
your car is moving and the GPS has to figure out whether you have to go, I mean, if the road is going straight or left or right or flyover, something, so that they can warn you in advance. Okay. So, so first thing is that they need to know whether it is road or water or grass, right? So that is example of classification. So first you are performing classification, and then that knowledge is run on customers database. When you say I want to go to XYZ restaurant, it figured out all the details, and then you say okay, a green, okay, so green field look like this, water will look like this. These are intermediary steps, these are not final steps. And now when you are
Mhm.
using the GPS on your car, on your drive, on your travel, that's when it's going to figure out, oh, okay, this looks like green, let me not go into, oh, this is like what, flower, let me take the flower and go, right?
Mhm.
You cannot give every description. Okay, it figures out the description from here. So here again you are doing two things, but first you are doing classification, then you are doing clustering. So okay, so we call it as clustering based on the outcome.
Mhm.
Okay, that's called lane finding GPS. Then you have optimized marketing. Okay, now let's say you are marketing manager of a company. Okay, for a big company or Amazon, let's say, and you've been given $100 million to run various marketing campaigns. Okay.
Okay.
Now that $100 million is for 1 year. So you cannot use complete $100 million at one go. So what you think is, okay, you say, okay, let me take only 9 million out of it and let me use this 9 million now. Okay. So you read about it, okay, various marketing strategies, and you say that okay, $9 million I'm taking, and I'm going to put $1 million in each of the channels. So there could be channels like Facebook ad, Google ad, TV ad, radio ad, paper ad,
Mhm.
so you'll have different types of ads. So you'll say okay, hoardings, right? You put details on the hoarding. You say okay, let me first spend 1 million on all of these ads. So you spend 1 million on all the nine, and then you wait for the result. After a month, when you get the result, you feel that you know uh, Google ad has done more business, has got more business to you. So what you'll
Mhm.
do is you will cut down slowly on the other expenditure next month. Next, you have already spent 9 million. Next one again you will take 9 million, but this time you will not distribute equally. The one that has done given you better result will probably give 1.5 million. And the last worst performing model has given you, let's say, less, and you give less. So 85 goes to, okay, to this list performance. Um, in this case, like marketing, right? So,
Mhm.
so earlier, let's say you had nine channels and
Each channel got 1 million.
$9 million. So you spend $1 million on each. Next
Mhm.
time also you have nine, but you are spending 1.5 to maybe 0.75 million, 0.5 million on the worst performing model. So what you have done, your action is based on the data that you have got from the previous step, from the learning from the previous step. So that's why we
Mm-hmm.
call it as reinforcement learning. You didn't know what to do, so you did something, spent $9 million, and waited for the output to see which is having more impact. Then, oh, this has more impact. Let me allocate more budget to it. So
Mm-hmm.
your budget allocation second month is based on the learning from the first month. That's why it's
Mm-hmm.
an example of reinforcement learning. Optimized marketing is a project,
Okay.
right? Did you understand this?
Yeah.
Similarly, you have driverless car. A driverless car is also supposed to be your reinforcement. Why? Because it is not possible to give all kinds of uh,
Scenarios to the.
scenarios. Exactly, it's not possible to give all kinds of scenarios to your model. So
Mm-hmm.
instead, you will give some conditions like red light, you have to stop, green you have to go, right? So you said okay. So so based on this feedback, okay, your algorithm is going to work, okay, so that you get the least chance of accident. So if you do this, more chance of accident. If you do this, less chance of accident. So now the machine will be able to figure out, okay, this less chance of accident. So let me try this method. Let me try this thing.
Mm-hmm.
Right? So that's what we call reinforcement learning. So we are not going to get into control kind of thing, but we'll look at say marketing kind of examples. Okay. So these are different examples and different types. So if you see, ultimately you're using classification, clustering, and regression only.
Mm-hmm.
Okay. So an association. So we are going to do these four algorithms only. Okay. Now these are your families of algorithm. Okay, not algorithm. These are regression is not one algorithm. There are many algorithms which form part of regression.
Mm-hmm.
Okay. So we'll stop here for today.
Okay. Can you like open your website and just go
One
to the link once?